Hey everyone, welcome to this video. We will talk about tokenization. And the reason why we care is because later on in the course, we will run this lstm.ipynb file and we will use tokenization. Okay, so let's say we have this text or string. I would karaoke often at the local park during my free weekends. I have gotten better at singing. We need to split the text for our model. Tokens are the split pieces of the text. And in this video, let's go over 4 different tokenizations. So, pop quiz. What are several different ways we could split up this text? The most obvious one I could think of is sense tokenization. There are 2 senses, there would be 2 tokens. What's the next obvious choice after sense tokenization? Word tokenization, where there will be 20 tokens. What's the next obvious choice? Character tokenization, where there would be 97 tokens. And a less obvious tokenization method is subword tokenization, where there would be 21 tokens. Let's go over all of these. So for sense tokenization, well, there would be 2 tokens because there are 2 senses, but there's an issue. Total possible senses is infinite. So a sense in the English language could be like 3 words, like I love you, or like 20 words, 30 words, 40 words, etc. Then there are thousands upon thousands of different words in the English language. And then if you have a sense of, like, say, 30 words, those words could be rearranged into a new sense. So the total possible senses is a really, really big number. So big that you could almost think of it as infinite. And that is an issue because total distinct tokens will be infinite, which is not ideal. What about word tokenization? Kevin is a teacher who teaches for the teaching club. The tokens would be split into these. However, an issue is that similar words like teacher, teaches, and teaching will have different tokens, and the model may not understand that these words are related. And while the total distinct tokens will no longer be infinite, there are still thousands upon thousands of unique words in the English language, or any other language really. So it's still not ideal, although it is an improvement. Okay, what about character tokenization? So hello world becomes these tokens right here. And there's a huge benefit to character tokenization. Total distinct tokens will be small. For example, in the alphabet, there's only 26 letters. Then you have punctuation and digits. But there's some major downsides as well. More tokens means more computation, which means it's going to cost more money. So for hello world, if we did word tokenization, we get 2 tokens, whereas for character tokenization, I don't know how many tokens this is, but as you can see, it's a lot more tokens than 2. Also, characters have less information than a word. For example, the token of just the letter O has a lot less information than the token for original, which means model performance can suffer. Despite these massive setbacks or weaknesses of character tokenization, it can still be used for spelling correction, text generation, such as names. And finally, let's go over subword tokenization. Words can be split. Teacher becomes 2 tokens, teach and ER. Teaches becomes 2 tokens, teach and ES. And teaching becomes 2 tokens as well, teach and ING. Can you think of a massive benefit of this? The model will know that teacher, teaches, and teaching are related. And now, instead of having an infinite number of tokens or a very big number still, now the total distinct tokens will be smaller. Okay, that's it for this video. Thanks for watching.